Hello, good morning, guys.
Good morning.
So in the last class, we discussed about, first of all, subnet mask. Okay, we saw about subnetting, and subnetting will be revising today also. Then we discuss about class A, B, and C addressing. Okay, how do we generate or create the networks, or what is the IP range in the class A, B, and C? Okay, what are the number of networks in class A? What are the number of networks in class B and C? What are the number of hosts per network? How many hosts per network you are having in class A, B, and C? We saw that. And after that, we saw a small concept about public and private addresses. So any doubt in that part? No? Okay. So today we'll be going again with the subnetting. So about subnetting, if you remember, what is subnetting? So subnetting is basically you divide the networks. Okay. And why do we need to divide the networks? That part we'll be seeing today. Here, if you see the definition, so subnetting means divide the network to economically assign the IP address to the devices. Okay, because we have only 4 billion addresses and we have to use those addresses. We have to divide those addresses very efficiently because number of devices is far more than 4 billion. Okay, so for that purpose, we have to use the subnetting. Now, there are two types of subnetting. One is the classful subnetting and second is the classless subnetting. So if we talk about your classful subnetting, so your classful subnetting is when you are using the default subnet mask. Means when you are using class A subnet mask with a class A network, this is classful subnetting. When you are using class B network with a class B subnet mask, that is classful subnetting. When you are using class C subnet mask with a class C network, that is classful subnetting. And whenever you change the subnet mask from the default subnet mask, let's say for class A, what is the slash value? 8/8. So if you change it to 9, this will become classless because it is no more the default subnet mask. The number of bits has changed, so it will become classless. Okay, but why do we need subnetting? So we'll see that. One reason to use the subnetting is to reduce the wastage of IP addresses. But first of all, we need to know how the IP addresses are getting wasted. Okay, so for that purpose, I'll create a small table for reference. One will be the class. Okay, second will be the number of networks. Okay, and third will be the number of hosts per network. Okay, according to the classes. So first of all, if we talk about your class A, so in case of class A, you are total having 128 networks. From the calculations yesterday, we can calculate this, that we are having total number of networks. How many? 128. But among the 128, we cannot use the 0000 and 127,000. So total we are remaining with 126. Okay, total are 128, but two networks we are not using because the first network 0.0.0.0 you cannot assign. Okay, and the 127.0.0.0 it is reserved for loopback. So two networks you will not be able to use. So total we are remaining with 126 networks. And if we talk about number of hosts per network, so how many host bits are there in your class A? 24. So if you calculate 2 raised to power 24, if you calculate 2 raised to power 24, this number is 1,67,77,216. This is the number. So this is the total number of addresses. Okay, total number of IP addresses. But again, from the total number of IP addresses, we cannot assign the first and the last address. First IP is reserved for the network ID and the last IP is reserved for the broadcast address. So means to your host or to your nodes, you can assign only from, if you subtract two addresses from these total number of addresses, those many addresses you can assign to your systems. So that means this will be 2 raised to power 24 minus 2. Okay, and this value will be just subtract 2, and this is the value. This is the number of IP addresses in one network of class A. You can assign these number of IP addresses from class A in one network. Okay, or ultimately you can think like this number of systems can be in a single network if you are using class A. Okay, then if we talk about your class B, so class B is having 16,384. Okay, how it is 16,384? Because in case of class B, you are having total 16 network bits, correct? But 2 bits are reserved. So 2 raised to power 14, that will be 16,384. Similarly, in case of class A, we are having 2 raised to power 7, that is 128, and 2 networks we do not use. So it is 126. And number of hosts per network, how many host bits are there? 16. So you'll say 2 raised to power 16. But again, first IP and the last IP we cannot use. So minus 2. And this will be somewhere around 65,534. These many IP addresses are there, or these many IP addresses you can assign from one network of your class B. Okay. Then if you talk about your class C, so class C is having total how many network bits? 24. Out of 24, 3 bits are reserved. So 2 raised to power 21. That will be 20,97,152. Okay. And how many host bit? 2 raised to power 8, because 8 host bit. And again, 2 addresses we cannot use. So total number of IP addresses will be 254. Okay. So in case of default subnet mask, right now we do not know about subnetting. Okay. So in case of default subnet mask, this is the scenario. So how many networks can be designed? If we see here total number of networks in IPv4, how many networks we can design? Somewhere around 21 lakh, right? This is 20,97,000. Okay, then 16,000. So somewhere approx 21 lakh networks. So are there only 21 lakh networks only in the world? No, right? There are far more. Okay. So
this 128.
Total is 128, but out
will be doing for 2 to the power of n-1, right? 2 to the power of 7 will be doing, right?
Yeah.
7
2 raised to power 7 is 128.
Yeah.
Then the first network 0.0.0.0 we are not
Then
using.
for second one, you have told 2 to the power of 16 should be, you have done for 2 to the power of 14, right?
Yes.
That is correct. That time we did not do -2, right? For the
See, remember, in case of class A, total 8 bits, right?
Yeah.
The first bit is always 0. Only 1 bit is fixed. Out of 8 bits, because total 8 network bits are there, right? So out of 8 bits, you have fixed 1 bit. So total is 2 raised to power 7. Now, the range of your class A is from 0 to 127. So out of this range, this first network you do not use. Yeah, because when I show you, when I try to assign the 0 network, your system is saying assign an IP between 1 to 2 to 3 only. So means this one you cannot assign. And this 127.0.0, this network, this is reserved for loopback. So again, we have to subtract 2 only in case of class A, not B and C. Because if we talk about the range of B, it is from 128 to 191. So there is no more reservations. Okay. Is it clear? Now let's say I have a small company. I have a small company. And in my company, I'm having around 50 systems. So which class network should I design? I just have 3 possibilities. I can either use class A, either use class B, or either use class C. So which is the best suitable for me? C. Okay, let's say I'm using class C. So in class C, I'm getting total number of addresses 254. These number of addresses I can assign my system. But how many IPs I'm assigning? 50, because my requirement is 50 only, right? What are the remaining addresses? What about these addresses? It is waste, because no one is going to use them. No one is going to use these addresses. Again, let's say my requirement is 300. Now what will happen? Class A cannot satisfy. Then class B. Now again in class B, how many addresses you are getting? 65,534. And how many I'm using? What is the wastage? 234. Can you see the wastage? So if we started wasting addresses like this, so will the 4 billion be sufficient? Not at all.
Sir, I don't know.
Yes, please.
Why we not use 3 bits in class A?
Huh?
Why we not use 3 bits in class A?
Class C networks.
Yeah.
You are saying total bits are 24, but we are doing it 2 raised to power 21. If you remember class C, in the first octet, to decide the class, we reserved 3 bits. And these bits were first bit always on, second bit always on, and third bit always off. So you cannot manipulate these 3 bits. So you are remained with the only 5 bits from the first octet. Second octet, you will get total 8 bits. Third octet, you will get total 8 bits. So 8 plus 8, 16, and 5, 21. Okay. Is it clear? Okay. So wastage is visible, right? How much we can waste. Or if you say, even if my requirement not 300 also, if it is 256 also, or 257 also, just because of one address, I'll have to use class B, and number of addresses I'll waste. And if these are the public addresses, let's say these are the public addresses. So companies or the ISP will be assigning you the entire network only, because we don't have subnetting. Right now, we are not talking about subnetting, right? So your ISP is going to assign a network only. So you have to pay for all these addresses. And then you will be using this much, and all your money for these addresses is a waste. So for this purpose, we have to go with the subnetting. Means we need a way so that we can divide these networks according to our need. Okay, clear? Is it clear? Okay. So why do we need subnetting? Is that clear? To economically assign IP addresses. And when we are talking about economically assigning IP addresses, we are talking about reducing the wastage of IP addresses. Okay. Now, how you are going to do the subnetting? So first of all, I'll take an example of class C. Okay. So I'm talking about class C, classful subnetting, when we are using the default subnet mask. Okay. So when we are using the default subnet mask, let's take an example. Let's say you have been given an IP address 192.168.0.10/24. This is the address you have been given. Okay. So looking at the /24, you can get some information. What is the information you can get here? About network bits, host bits, correct? So from here, I can know number of network bits is 24, correct? Host bits equals to 8. This is the information I received. Now, when I know the network bit and host bit, I can write the subnet mask, because I know in my subnet mask, network bits are denoted by 1 and host bits are denoted by 0. Okay. And all the network bits or all the ones will be on the left side and all the zeros will be on the right side. Okay. So if you write the subnet mask, so it will be like you have 24 network bits, 16, 24. And now I have to write 8 zeros. This is my subnet mask, correct? Now, if I write it in decimal, this is the value. This is the value. Okay. Now, first of all, I need to calculate how many networks I can design. So in case of class C, okay, we are using the default subnet mask for classful subnetting. Okay. We are using the default subnet mask. It means when we are using the default subnet mask, 3 octets are for network and 1 octet for host. So we will be designing only one network. In case of default subnet mask, you will be designing only one network. We'll be breaking down the networks when we are doing the classless subnetting. Okay. So if I want to calculate number of hosts, or you can say simply block size. What is block size? The number of addresses in your IP range. Okay. If you calculate block size. So block size, you can calculate 2 raised to power host bit. This way, you can calculate your block size. So here, number of host bit is 8. So 2 raised to power 8 is 256. This is the value. Now, if we have these 256 addresses, we'll be starting from the 0 and going until the end. Okay. So looking at this, if you look at this IP address and /24, you will come to know that in my IP address, I have 3 octets for network, because 24, right? Sorry. And this 1 octet is for host. This is the value. So I have to keep constant these 3 networks, and my host part is going to start from minimum and go until maximum. Okay. So 3 octets are same. 0 dot starting from minimum, the first address. Okay. Then we will have the last address will be 0.255. Last address I'm talking about. Okay. And the second last address, or the last valid IP, you can say 254. This is the value. Okay. And in this case, the first will be your network ID. Then we will have the first valid IP. We will have last valid IP and the broadcast address. Clear? This is the classful subnetting. Now, what kind of questions you will get? You will be given an IP address with a subnet mask. Okay, you have been given, let's say 192.168.0.10/24. And you will be asked what is the network ID and what is the broadcast address. So looking at this IP, what is the network ID and what is the broadcast address? Tell me. You have been given this IP 192.168.0.10 and /24. And you have been asked for the network ID and broadcast address. So what is the network ID and what is the broadcast address for this particular IP? 0.0 is the network ID, and the last IP will be our broadcast, that is 0.255. Okay. This is the network ID. This is the broadcaster. So this kind of questions you will get. This is the example for class C.
If you don't mind, Ajay,
Yes, please.
I want to know that /24 is the net.
/24.
I didn't get.
Okay. So what is the slash notation basically? It is you write a slash, and then in front of the slash you write number of network bits. This is the notation. Okay, instead of writing subnet mask every time, you can denote it like this. Even your subnet mask tells the same thing, how many network bits and host bits. Okay, so this slash notation will also be known as something sometimes like CIDR value or prefix length, like this. Okay, so basically whenever you see the slash and any number in front of it, like 24, so basically it is giving you the information that you are having network bits 24. And total bits in your IPv4, there are 32. So you can subtract the network bits and you'll get the host bits also. That is 32 minus 24, that is 8. Is that clear?
Yes, Ajay. Thank you.
Okay. So any doubt? Is it clear? Okay. So you can calculate now, right? The network ID and the broadcast address. So if you have been given an address like, let's say 200.3.7.77 and /20, what is the network ID and broadcast address?
200.3.7.4.
What is the network ID? 200.3.7.0, because only last octet is the host. 3 octets are network, so they are going to remain constant. So the host part or the host octet, if you make it minimum, that will be your network ID. If you make it maximum, that will be your broadcast address. So just looking at the address itself, you can tell 200.3.7.255. This is your broadcast address. Okay. Okay. Now we'll go for class B. So we are saying class B, classful subnetting. So let's say I'm taking an example 173.16.0.10/16. Again, the information from here, network bits, you'll get 16. Host bits, 16. You'll write the subnet mask. Written. Then write in decimal. Correct. Now calculate the block size. So block size, how many host bits are there? 16. So if you calculate 2⁻16, that is not 14, 16. 14 we'll be doing in the case of number of networks if we are calculating in total class B. Right now we are just talking about one network of your class B. Okay. So 2⁻16. So this number is somewhere around 65,536. How we are going to divide the range? How we are going to divide the range? So to divide the range, what you can do, because if you see here, what we are having is, this is for network, for host, and for host. So for host, we are having 2 octets. Okay. So means we will have to calculate 2 separate block sizes. One is for the 3rd octet and one is for the 4th octet. Okay. But just looking at the address, again, you can go simply like, okay, if you have to write the network ID, you can say 173.16.0.10. So these 2 octets are host. So if you write minimum 0.0, it will be your network ID. And what will be the broadcast address? 255.25. But when we are doing the subnetting, that time we'll have to calculate 2 different block sizes. Right now we are doing classful. So we are having complete octets, either network or host. But when we'll be doing subnetting, there will be octets that will be having the network bits also and host bits also. Okay. So that time we'll have to calculate different block sizes. Okay. So total number of host, how many? 16. 2⁻16, that is 65,536. But I cannot put this value in either of the octet. No possibility. Okay. So simply you can calculate the value. Simply you can calculate the value. How do you calculate the value? So you can say block size of the 3rd octet. So when we were calculating the total block size, we were calculating with the total number of host bits. But right now we are calculating for the 3rd octet only. So how many host bits are there in the 3rd octet? 8. Okay. So you will do 2⁸8. So how much? 256. Okay. Okay. Then block size of the 4th octet. That is again 2⁸8. How much? 256. So we have 2 block sizes now. So to start with the first address, we will have to make the host part minimum. Host part minimum. So I'll be saying my network is 173.16 and host part minimum means 0.0. Okay. And if you want to calculate the next network, next possible network, So that will be, you will have to add these block sizes in your host part. But 256 is not possible. Means we will not have another network. We will not have another network. Why? Because 256 value in one octet is not possible. Okay. So simply means you will have just one network and the value will go to, it will be like 173, the first IP, 16.0.1, and the last IP will be having 173.16.0.255, and before that 173.16.0. Sorry, host part completely maximum 254, because host bits, they will go from minimum till maximum. So we are having 2 octets for host, means those 2 octets will start from 0 and go until 255. Okay. And if we had another network, that will be having in the case of classless. Okay. So that time we'll see that we have to add these block sizes in your second network if you want to know your second network. Okay. So again, in this case, this is your network ID. This is your first valid IP. Then we have last valid IP and broadcast address. This is the information. And the questions you will be getting, they will be, you will be given an address only. Okay. Like 173.16.0.100/16. So what will be the network ID? And what will be the broadcast address? 16.0.0 network ID, and host part maximum 173.16.255.255. This will be your broadcast address. If we take another example, let's say 130.33.74.6, and you have been given /16. So what is the network ID and what is the broadcast address? Yes, 130.33.0.0, because host part minimum and host part maximum 130.33.255.255. Clear? What kind of questions you'll be getting and how you're going to answer them? Just looking at the address, you can answer them. Correct? Okay.
So your block size means the number of hosts per network.
Yeah, this block size means when we are talking about total block size. When we are calculating block sizes for particular octets, that time we are doing so that we can design or we can know what are the possible networks, what are the possible network IDs. Okay, this part you will understand when I start the classless. Okay, I'll be showing you how you can calculate that. Okay, what will be the next network value? Otherwise, how will we know that this is the first network ID? For second network, this will be the network ID. So to know that, we will be calculating separately the block size. Okay.
Ajay, if suppose, see, if you're taking the like 173.16.0.10 instead of that IP address, if you take 173.16.1.0.10, then the block size will be changed, right?
173 dot
173.16.1.0.10.
No, it will not change because the block size completely depends on your slash value.
No, I'm asking in the first class B.
Yeah, we are talking about class B, this one, right?
No, over here.
This one?
First one. Yes.
Okay.
If we take the value IP address as 173.16.1.1.10. Yes.
Okay.
Now, instead of 0, it has counted as 1, right? So that
Yes.
it will change to the 1111 and octet will be 3. I mean 255.255.255.0.
Actually, this value.
Yes.
This is being calculated from this.
Okay.
Okay. So it entirely depends on the subnet mask or your slash value. Okay. This is going to decide what is the block size and how many networks are there, what are the number of addresses are there. Everything is decided by this value, slash value. Okay.
But if you said like if the 0 in IP address is the 0, the left side it will be count as 1, and after once if you get the 0, and the rest of values are also 0. But here what I said is 173.16.1.10. There is no actually 0, right? Then how you will calculate in this?
See, the thing is this value. Okay.
Okay.
It is going to tell you that first octet is the network. second octet is the network. So only these two octets are going to remain same. This octet can change.
In the power of 16. Okay.
Yes,
Hmm.
this can change.
Okay.
It would make a difference if it is /24. So in case of
24, huh.
/24, this would be also network.
Oh,
Means we have to
okay,
keep
okay.
this one also constant.
Constant.
Okay, that time if it is going from 0 to 1, the block size or the network would change.
Oh, okay. Instead of 24, if you take the 32, then whole 1, 2, 3, 4. 4 will be your
/32,
network, right?
it is not possible actually. And I'll be telling
Okay.
you why. Because if you say /32, okay.
Okay.
So
Huh.
number of network is how many network bits?
4 network bits, I guess.
No. How many network bits?
Huh.
In front of slash we write network bits, right?
Huh.
So it is /32. So means 2 raised to power 32 networks.
32 networks.
Correct.
Huh.
So means total 4 billion networks, 4.3 billion
Right.
networks.
4.3. Yes.
And how
Okay.
many host bits we have? So to calculate the host bits, what we'll do? We'll subtract total number of bits is 32 and we'll subtract the network
32?
bits.
Okay.
So what is
0.
the host bit? 0. And 2 raised to power 0 is 1.
0.
Means you are only
sorry,
having
1.
one address. So either you can calculate it as either you can consider it network ID or valid host or broadcast. What you are going to calculate? Consider it.
Okay.
Okay. So /32 is not possible.
Okay. Instead of 32, if you take 8. 8.
Yeah. Okay. /8.
Okay.
In case of /8,
Then-
again you have 8 network bits, right?
Huh.
So network bits 8 means your first octet is the network and remaining 3 will be host. So you
Okay.
have to keep this octet only constant. And
Only
remaining
one
3
constant.
Yeah.
Zeros.
Only the network part is going to remain constant. The host part is going to change from minimum to maximum.
Change. Minimum to maximum. So in this only in the /8 we need to count only first is the
Yes.
octet is the network.
Yes.
And the rest of our host. Okay.
Yes.
Thank you.
Okay.
So,
We are coming to class A, so we'll understand /8 also. So this is clear. Class B, classful subnetting. Yes, please.
Can we say that one network we use minimum 254 hosts?
One network we use. In case of class C, you can say that
Minimum 254 in any class.
minimum. No. Minimum you can use 2 also. In one network, minimum you can have 2 addresses also. That totally depends on your subnetting. Okay. So class B, clear? Okay, next we have class C. Oh, class C we have done. Class A, I mean. Okay. Class A, classful subnet. So you have been given an address, let's say 1.1.1.1/8. Okay. So looking at this address, you will get the information. Network bits 8, host bits 24. So you have to write the subnet mask. So how you are going to write? 8 network bits done and remaining 24. Okay. Write the subnet mask in decimal 255.0.0.0. Okay. Block size, total block size, if you calculate, that will be 2 raised to power 24. Okay. That will be 1,67,77,260. Okay. Now to write the IP range, we have to start host part from minimum and go until maximum. And the network part, it is going to remain same throughout the network. So from here, we got the information that 8 network bits, okay, means the first octet is the network and remaining 3 octets are the host. So we have to keep the first octet constant and remaining 3 octets we can change. Okay. So how we are going to change? I'll say this is constant. Now host part minimum is 0.0.0. First address 1.1.1.1. Then 1.255.255.254, 1.255.255.25. This is the last address. Okay. And here, this is the network ID. First valid IP. Then we have last valid IP and broadcast address. Okay. This is how you can calculate. Now, type of question you can receive. Again, let's say if you consider about this, our example 1.1.1.1/8, and if you are asked about network ID and broadcast address. So your network ID will be 1.0.0.0. Oh, sorry. Yes, my mistake. 1.0.0.1. Correct. This is my mistake. Sorry. 255, 255, 25. Okay. This is my mistake here. Let me change. Should be 1.0.0.1. Is it correct? Okay. Another example, 13.10.7.23/8. So what is the network ID and what is the broadcast address? So network ID is 13.0.0.0 and broadcast address is so classful subnetting clear, right?
What does the block size actually means?
Block size actually means the number of hosts in your network. Okay. How many IP addresses you are getting in your network. Whatever network you are designing in that network, how many addresses you are getting. That is your block size. So class A, B, and C, classful subnetting is clear to everyone. Next, we'll be doing classless subnetting. Okay. So first of all, we'll do classless subnetting for class C. Okay. Class C, classless subnetting. Okay. So what is the default? If I consider the default subnet mask, what is the default subnet mask value? 24. Or if I write it in binary, default subnet mask in binary, DSM means default subnet mask. Okay. So that will be, this is the value, correct? Okay. Now let's say the example you have been given is, you have been given 193.168.0.90. Okay. And this time, instead of /24, you have been given /25. Instead of /24, you have been given /25. Now, from this IP address, the information we are going to receive is, what is the network? Network bits. 25 we are having this time, and number of host bit 7. So we have changed from the default subnet mask. Default is /24. Now we are going with the /25. Okay. So again, write the subnet mask. So the subnet mask will be how many? 24. Correct. And 1 bit we have taken from the host part. Correct. 1 bit we have taken from the host part, and remaining 7 are what? Host bits. Correct. You have to write 25 ones and 7 zeros. All ones will be on the left, all zeros will be on the right. Okay. So if you calculate this value in decimal, this will be 255, 255, 255 dot, what will be the value? 128. The value will be 128. So means your subnet mask has changed. If you calculate this value in your decimal, this will be 128. Okay. Now let's talk about the block size. So we are going to calculate the block size. So block size will be number of host bits, 2 raised to power number of host bits. So we are going to say 2 raised to power 7, and this value is 128. You got the block size. So from here you came to know that in one network right now, according to this IP address or according to your /25 subnet mask, we came to know that whatever network is being designed in that network, I'll be having only 128 addresses. Only 128 addresses. Earlier I was having 256, 2 raised to power 8, when we were having 8 host bits. So we were having 258. But as soon as I just took, or I just borrowed 1 bit, I just borrowed 1 bit from the host, and my number of IP addresses changed to 128. And if you want to calculate the number of networks, how many networks will be designed? So you can calculate like this, number of networks. How you can calculate? 2 raised to power number of borrowed bits. How many bits you borrowed? Only 1 bit we borrowed. Correct. From the host part, how many bits we borrowed? 1. So we are going to say 2 raised to power 1. Means how many networks are going to be designed? 2 networks. So simply what is happening here, when you are having /24, okay, you are getting 256 addresses. This is correct. As soon as you change or borrow 1 bit only, this one network will get divided into 2 networks of 128 each. You are breaking down your network of 256 into 2 different networks of 128. And this is how you are getting this block size. Is it clear? Now see, we got the number of networks that we will be designing 2 networks, and we also got the block size. Now the first network we have to design. So how many octets are for network? First octet is it is totally network. Second octet totally network. Third octet totally networks. Means these 3 octets at least we have to keep the same. These 3 octets we have to keep the same. And for calculating the first network, we will be doing this octet minimum. We will be starting because addresses always will start from 0 only, right? So the first network you are going to design is, what is your network? 193.168.0.0. Correct? This is one network design. Now we have to know what is the second network. So to calculate the second network, what we can do, we can just add this block size in the first network. How we can add? So if you see this block size or these host bits are available in which octet? 4th octet. So just add this block size in the first octet and your new network IDs, the second network ID will be. Is it clear? Clear, right? Now, if my second network is starting at 128, means my first network will be ending somewhere 193.168. Where? 1.0.254. Why? Because my next network is starting at 128 and I'm having in one network, I'm only having 128 addresses. So means my first network will be ending at 127. Okay. Is it clear? Okay. Just once. See what is happening. This is my first network. I'll have to do the host part minimum. I did the host part minimum and I got my first network. To calculate my second network, I just added the block size wherever I was having the host bits. Okay. Anywhere I was having the host bit, that was the first 4th octet. So in the 4th octet, I added the block size and I got my second network. Okay. Now, how many addresses are there in one network? 128. So either I can directly say that 128 addresses means 0 to 127. Or I can calculate like my second network is starting at 128. So means my first network is ending at 127. That's why a new network is being designed. Because ultimately what you are doing, this single network only you are dividing it into 2 different networks. We are breaking down one network into 2 smaller networks. This is only subnetting. Okay. So according to this, if I want to calculate, okay. So according to this, if I want to calculate the first valid IP, what will be the valid IP? 193.168.0.1. And what will be the last valid IP? 126. Okay. Similarly, in the same way, 193.168.0.129. Okay, tell me one more thing. If I had to design one more network, although I know I have to design 2 networks only. Okay. So if I have to design one more network, the network ID would be something like, if I add 126 again, so it will be 193.168.0.256. 128 plus 128 is 256. 256 value is possible? Not possible. But still, let me consider, okay, it is possible. So if I was designing my third network, it would be 256. So where my first network would end? 255. This is one way to calculate the broadcast address. Another way, always remember, whenever you are writing the network IDs, so always remember the last network ID will always be same as your subnet mask. The last network ID will always be same as your subnet mask. In your subnet mask in the 4th octet, it is 128. So here also in the 4th octet, you will have 128. And if you have this, means this is your last network and this network is going to go until maximum. This is how you calculate. Okay.
So
Yes.
the last octet also there is one network there. That's why we are supposed to use the second network, right?
Yeah.
Second network will use. If we consider both the networks, then it will become classful at the same time.
Yeah. No, totally depend on, again, your slash value, because your slash value will decide how many networks will be there. So as soon as you say it is 25, means you have borrowed 1 bit from the default. And if you have borrowed, then again, see here, one more thing. Just let me finish this range and I'll explain with the examples what kind of questions you'll get, and there you'll understand. Okay. So the last address of this will be 193.168.0.255, and it will be 193.168.0.254. Okay. This will be your network ID. Now we are having 2 different networks, means 2 different network IDs. First valid IP, this will be the last valid IP, and this will be the broadcast address. Okay, now understand. Let's see what is happening here. So you have been given an example, 193.168.1 is our same example, 0.90, and with the slash 25. Okay. And you have been asked for the network bit, network ID. and broadcast address. So you have to calculate. Now, to know the network ID and broadcast address, we will have to do this calculation. Okay. And if we are doing this calculation, we came to know that how many block, what is the block size? 128. Looking at the block size directly, you can say my first network is going to have 128 means 0 to 127. And the second network will have the remaining range 128 to 255, because ultimately this is also having 128 addresses and the second is also having 128 addresses. Now looking at this particular IP, in which range it is falling, in this range or the second range? First one means your network ID and broadcast address will be from the first range. Okay. Yeah, because we have divided it into two networks, we will be having two different network IDs and two different broadcast addresses. So we cannot combine them when we are using. Yeah, subnet mask will not change. Whether you are using an IP from this range or this range, it will be the same subnet mask you have to assign in the system. Okay.
It's 90 or 80, 70, whatever.
Anything. But subnet mask will remain same. Is it clear? So your network ID will be 193.168.0.0 and broadcast address will be 193.168.0.127.
What will be the starting for 90?
What will be the
Starting with 91.
this is ranging from 1 to 126, so it is the total sequence 90, 91, from 1 till 126 total IPs. Okay. Now let me give one more example. What if the IP is 193.168.0.140? Network ID and broadcast address 128 will be the network ID and 255 will be the broadcast address. This is the broadcast address. Okay.
Okay.
Yes, please.
So this slash value can go to maximum 32, correct?
Last slash value.
Yes. For class C.
Generally, we will be going until /30 only.
/30.
Okay. Yeah, because even again /31 means you are having 31 network bits and only one host bit.
Correct.
So if you take the number of hosts 2 raised to power 1, only 2. So either only 2 means network ID and broadcast address. Okay. But this /31, this has a special case. It is a tiebreaker and it does not follow your subnetting rules. And I'll explain why. Because generally, or in some books, you'll see you cannot use /31. But I'll show you, you can use it. Okay. Your /31, it can be used for only point-to-point networks. Okay. Because when we are having only two devices, simply understand, when we are having two devices, so they both are connected. We are not having a network, right? We don't need a network ID and broadcast address because only two devices. So for two devices, why do we need a broadcast address? Broadcast is one-to-all communication, right? But ultimately, either I do unicast, multicast, or broadcast anything, I'll just be talking to this one system only. So why do I need the broadcast address and all? So /31 is the tiebreaker. It does not follow your subnetting rules. Okay. So
Sure.
anywhere when there are only two devices, generally I'll configure it on two routers and I'll show you that here you can use the /31 network. Yes, please tell me. I'll be giving you practical for this. I'll show you how to assign. So yes, tell me any doubt, or is it clear? Okay, then let's move to class B. Before class B, I'll take one more example for class C to make it more clear. So always remember for subnetting, you can go until /30. Okay. /31 is a special case and /32 we cannot use. Okay. /31 is only used in the point-to-point network. Okay. Again, class C, classless subnetting. Okay. So this time, let's say you have been given an IP address, or let me take the same IP address, only 193.168.0.90. But instead of 25, let's say you have been given 26. You have been given 26. So means the information you will receive is network bits. How many? 26. What about the host bits? 6. Okay. What will be the subnet mask? Subnet. This time we are borrowing how many bits? 2 bits. Correct. And sorry. This is the subnet mask. Calculate the value 255.255.255 192. This is the subnet mask value. Okay. Number of networks we want to calculate. So number of networks is 2 to the power number of borrowed bits. How many bits we borrowed? 2. So this is total networks we will be designing is 4. Let's calculate the block size. This is 2 raised to power host bit. So 6 host bit. And then this value will be 64. Again, we have to design the first network. You can say 193.168.0.0. The second network I want to design is 193.168.0.64 because I'll be adding the block size. Again, 193.168.0.128. And the last network, 193.168.0.192. Because how can I calculate the last network? Simply I'll check the subnet mask. The subnet mask is my last network. This is it. Okay, my subnet mask is 192 means my last network will always be 192 only. Okay. All right. Now we have to write the first IPs, first valid IPs. So the first valid IP will be for this network 193.168.0.1. For this network 193.168.0.65. For this network, it will be 193.168.0.129. And for this network, it will be 193.168.0.193. Okay. And then this will keep on going until the last addresses. So last address I want to calculate for the first network. So my second network is starting at 64. So my first network will end at 63. So 193.168.0.63. So last valid IP will be 62. This is clear. Okay. What about this? What will be the last address? 0.127. And this will be 193.168.0.126. Then the third 0.191. 190. Now the last address after the last network, we are not having any network means it is going to go until maximum. Okay. So means 193.168.0.255, 193.168.0.254. Okay. Then these all are our network IDs. This is the first valid IP. Then last valid IP. And then we have broadcast address. What is the network ID in broadcast address? So network ID will be 168.0.64 and broadcast address 193.168.0.127. Easy. Similarly, if you are given, let's say 200, you have been given 193.168.0.200. So what will be the network ID? 192 will be the network ID and 255 will be the broadcast address. Okay. Is it clear? Okay. So class C, classless subnetting clear? This subnetting is really important. So if you have a doubt, you can ask me. Otherwise, this is going to create issues. Clear? Okay, we'll move to class B. Class B, classless subnetting. Okay, so what is the default subnet mask? 16 ones and 16 zeros. Okay, so let's say you have been given an example 173.16.0.10 and /17. Okay, now what will happen? Number of network bits 17. Number of host bits 15. Subnet mask 17 ones. And then remaining all zeros. Okay, 255, 255, 128.0. Is it clear? Okay. Now see the first network. Oh, before that, number of networks we want to calculate. So number of networks equals to 2 raised to power. How many bits we borrowed? 1 bit we borrowed. Again, 2 raised to power 1 means how many networks we are going to have? 2 networks. Okay. Now, if you see, the hosts are available in 2 different octets. Hosts are available in 2 different octets. So first of all, if I calculate my total block size, okay. So my total block size will be 2 raised to power 15. This will be a big number, somewhere around 32,000 almost. Okay. So I cannot have 32,000 addresses in one octet. So either what I can do, I can divide this with the 2, I mean 256, because in one octet we will have only 256 maximum. So either what I can do, or let me just calculate and show. So let's say we are having 2 raised to power 15, 32768. I cannot have this many number of addresses or this value in any octet. Okay. So what I can do, either I can divide it with 256 and I can know that what is my block size. Okay. So if I divide, let's say 32768 and I divide it with 256, 128. Okay. So either you can know it like this, or let me tell you a simple way what you can do. This is the total block size. Now hosts are available in 2 different octets. Okay. So first of all, calculate 3rd octet block size. Calculate 3rd octet block size. So what is the 3rd octet block size? 2 to power 7, because in the 3rd octet we are having only 7 host bit. So 2 raised to power 7 is 128. Okay. Then 4th octet block size. What is the 4th octet block size? 2 raised to power 8. That means 256. Okay. I think I did. Visible? Is it visible to everyone? Okay. Now I have to design first network. So for first network, again, I will keep 2 octets constant, and the 3rd octet and 4th octet I'll set to minimum. So I'll say 173.16.0.0. This is my first network. Now I have to design my second network. So for the second network, if you see in which octet there is a change, 3rd octet, remaining octets are all same, the 1st, 2nd, and the 4th. So means in the 3rd octet block size, in the 3rd octet, I'll add this block size. Okay. So what I'm going to do, I'm going to add 173.16.128.0. 128.0. Okay. Because if I try to add this in the 4th octet, this is not possible. This is not possible. Okay. Because see how it actually works. Your 3rd octet block size is 128 and 4th octet block size is. So if you want to calculate first network, you will be starting from 0.0, 3rd octet also 0, and 4th octet also 0. And then second value will be in the 3rd octet 128 network ID, because block size is what? 128. But if you calculate add 256, is it possible? Not possible. So we'll not be taking this one. Okay, like you can follow, you have calculated the block size, so you can follow one more sequence here. In here, you can write 2 more things. That 3rd octet block size in sequence. This is just for understanding. If you understand, then only they write this. Otherwise, you can generally understand this. In sequence. Okay, so what we do, we start from 0 and keep adding on the block size 128. And we only go until the subnet mask. That's it. If we write 4th octet block size in sequence. So in the 4th octet, only one possible. Why? Because it is 0, means starting from 0. And next, if I add 256, it will be 256, but it is not possible. So means I cannot use this. Now, when I have to design network, first of all, I'll start with the 3rd octet value. First of all, I start with the 3rd octet value, means 0.4. In 4th octet, what? Only one value is there, 0. Then again, 3rd octet value, 128. Only one value, 0. No more values left. So either you can understand like this, or you can simply see one thing, that in which octet there is a change. Just focus on that octet. 3rd octet is the change. So just add the block size of the 3rd octet. That's it. Nothing else. Okay. So if my second network is starting at 128.0, what will be the last address for my first network? 173.16.255. This is clear to everyone. The first IP 173.16.0.1. 173.16.127.25. 173.16.128.1 And after this, there is no network, means it is going to go until maximum. So what will be the maximum value? 173.16.255.254 and 173.16.255. And this will be 254. Okay. Then this is the network ID, first valid IP, last valid IP, broadcast address. Clear?
So for the given IP 193.16.0.110, first the networks
Network ID and broadcast address will be 0.0 and 127.255. 173.16.0.10/17 you have been given. So the network ID will be and the broadcast address. So it will be 173.16.0.0 and broadcast address will be 173.16.127.255. Clear?
/23 will come under class B.
Yes. See what happens when we are talking about subnetting, we are not belonging to any class. Okay. So in case of class C, let's say when we are doing about class C, classless subnetting. So 24 is the default. Now you can go from 25 till 30. Okay. In case of class B, this is class C, 16 is the default. Now from 17 till 30, you can go. Okay. In case of class A, 8 is the default. You can go from 9 till 30. Okay. Is it clear? So when we are talking about classless, we don't belong to any class. We are talking about classes only and only if we are talking about default subnet mask. Otherwise, it is totally classless. Okay. Is it clear? So let's say for class B, I'll give you an example with /25 or /24. Or maybe if you want, we can have /30 example also. So let's say you have been given an address 180.0.0.1/30. Easy. We can go until 30, right? So from here, you got the information. Network bits are 30. Host bits are 2. Subnet mask. Now remaining all the bits will be borrowed bits. And 2 bits will be the host. Correct? So if you write this 255.255.255.252, this will be your subnet mask. And if you calculate number of networks, so 2 raised to power, how many bits you borrowed? 8 plus 6, 14. 14 bits we borrowed. So 2 raised to power 14. And 2 raised to power 14 is 16,384. Okay. 16,384. These many networks you are going to design. So when we are talking about /30 of class B, means one network of class B, you have divided it into 16,000 networks. Okay. And if you calculate the block size, so 2 raised to power 2, because only 2 host bits are there. So what is your block size? 4. So 4 is your block size. Now see, if you want to start the first network, we have to keep the host part minimum 0. So what I'll do, I'll say 180.0.0.0 because we are having host in the 4th octet, right? So we'll start from 0. Now next network, for next network, we will add the block size. So from which in which octet the host bits are there? 4th octet. So keep on adding it. So the second network will be 0.4, then will be 8, 12, 16, and like this. What will be the last network? Like this. Yes, please.
Classes subnetting. Even though we are not considering the subnet mask, but we are considering what actually the class belongs to. Means it will be how much more we need to add from that initial subnet mask. Is that correct?
See, we are not belonging to class. I'm just showing you that when we are dividing a class B network when we are using a class B network with a /30 subnet mask. So what basically is happening, we have to keep 3 octets constant. We are not belonging to class. We are not talking about class. Everything is totally dependent on your subnet mask.
Like from your example, it seems like it's a B class, for example.
Yeah, just for example, I'm showing why, because whatever we have studied so far, so I have shown you that in one network of your class B, we are having 65,534 addresses. Okay, but what if you only require 2 addresses? So means you can use a very small portion of a class B network. Instead of using entire network and wasting thousands of addresses, we can use a small portion. We can use a portion of only 4 addresses, where 2 addresses will be reserved for our network ID and broadcast address, and we'll be having 2 addresses for host. This is the perfect thing, right? If you are having 2 hosts, /30 is the best, because 0 waste is 2 addresses for network and broadcast and 2 addresses for host. Clear? How we know? By looking at the first octet, 180. By looking at the 180, we can know it is from class B, because to check the class, we just look at the first octet. Okay.
So just for reference, which can belong?
Yes.
We need to add how much the slash.
Yes, just reference I'm showing you. Otherwise, what in case of subnetting, you will always just be seeing the subnet mask and calculate all the things. Okay. Once you are familiar that how many number of hosts are there in /30, /29, /28, so you will not even look at the class. You don't have to calculate, okay, how many networks we are designing and all. No, because you will be directly focusing, okay, /30 means we will have 4 addresses. 4 addresses means 2 are for network, 2 are for host. So I mean 1 network and broadcast and 2 are for host. That's it. Okay. So if I want to design the last network, I'll just look at the subnet mask 252. So means my last network, it is going to be something like 180.0.0.252. And if I want to write the second last also, it will be something like 180.0.0.248. Okay. Now the first valid IP is 180.0.0.1. For this, 180.0.0.5, 180.0.0.249, 180.0.0.253. Okay. So this is how it works. Then only 4 addresses are there. Means the last address will be 3. It is starting at 4, right? So last address will be 3 and second last will be 2. So means last valid IP will be 2. Sorry. And the last IP will be 3. 180.0.0.6, 180.0.0.7, 180.0.0.250, 180.0.0.251, 180.0.0.254, 180.0.255. So these will be your network IDs. First valid IP, last valid IP, and then we have the broadcast IDs. Clear? Now let's say you got a question that 180.0.0.80/30. So what will be the network ID and what will be the broadcast address? What will be the network ID and what will be the broadcast address? So see how you are going to calculate this. If you check what is your block size? 4. You will start at 0, correct? You are going to start at 0. Next will be 4, 8. Somewhere it will come 40, yes or no? And there will be a place where it will come 80, because it is divisible by 4, right? If you check from the block size, you can easily calculate that 80 means it is itself a network ID. So network ID will be, because before 80 there will be a network 76, and after 80 there will be a network 84. Okay, so one network will be from 76 to 79, 82, 83, and 84 to 87. So means your IP is belonging to this network, and network ID is 80 and broadcast address is 83. Clear?
Can you repeat this?
Sure. See what is happening. Your block size is what? 4. So if you write this block size and start designing the network, we always design the network from 0. And to calculate the next network, we keep on adding the block size only. So we will keep on adding 4, 8. So means multiple of 4 we are going. Okay. So means 10 times the 4, 40, 20 times, it will become 80. So before 80, what will be the network? 76. And after 80, what will be the network? 84. And we are having only 4 addresses. So means if this is starting at 76, 80 and 84. So means my this network will end at 79. It is starting at 84 means my this network will end at 83. So I got the network ID in the broadcast address. Okay, this is how you can calculate. So for this 180.0.0.80 itself is the network ID, and 180.0.0.83 is the broadcast address. This is how you can calculate. Okay, one more example. Let's say you have been given the address, or let me give some random address. Tell me. Network ID and broadcast address. Oh, slash value. It's the 30 only. Right now we are calculating 30, right? So 0, 4, 8, 12, and 16. So 16 is network ID, means 15 is what? Broadcast address. Okay. And if 15 is the broadcast address, means 12 is the network ID. So 145.0.0.12 is the network ID. 145.0.0.15 is the broadcast address. This is how you can calculate. Clear? So class B subnetting clear? Let's go to for class A. Same calculation, same way. The method is the same. Okay. Class A, classless subnetting. Okay, default subnet mask 8 ones. Okay. Address you have been given, let's say 9 dot, or easy address 1.1.1.1/9. Okay. So network ID, network bits 9. Host bits. How many host bits? If we are having 8 network bits, 24 host bits are there. So if 9 means 23. Total are 32, right? Total IPv4 bits are 32. So now see, subnet mask you have to write. Then, okay, 255.128.0.0, correct? Okay. Number of networks. So 2 raised to power 1. How many networks you are going to design? 2 networks. Okay. And what is the block size? So right now, instead of checking each and everything, I can see that the change is there in the second octet only. So I'll just calculate second octet block size. Okay. So I'll say second octet block size. And what is the second octet block size? 2 power 7. That means 128. Okay. First network I have to design. So 1.0.0.0. Correct. Second network, if I have to design, my second network will be 1 dot. I'll add the block size. So 1.128.0.0. Correct. So if my first network is starting at 1.128, means my first network will be ending at 1.127.255.255. Correct. And the first valid IP will be 1.0.0.1. And the last valid IP will be 1.127.255.254. Then the second network first valid IP will be 1.128.0.1, and the last valid IP will be 1.255.255.254, and the broadcast address will be 1.255.255.25. So this will be my network ID, first valid IP, then last valid IP, and we have the broadcast address. Like this we can calculate. Okay. So if the IP is your 1.1.1.1/9, so what is the network ID and what is the broadcast address? 1.0.0.0 and 1.127.255.25. Okay. All right. So if I give you a random IP also, let's say 9.9.9.9/9. Okay. So what will be the network ID and broadcast address? 9.0.0.0 and 7 sorry, 9.127.255.255. This is clear. So this is how you can calculate. Clear? So with class A, let's take a /30 example or /28 example we'll take. Okay, so IP you have been given is, again, let's consider 1 dot or 100 dot, 100 dot, 100 dot. This is class A, correct? And let's say you have been given /28. So what is the network number of network bits? 28. Number of host bits? 4. This is the information we have. Okay. Subnet mask. This is the first octet by default. 24. And remaining 4 will be zeros. Correct? 255, 255, 255.240. This is your new subnet mask. Okay. Calculating number of networks is equals to 2 raised to power number of borrowed bits. How many bits you borrowed? 16 plus 4, 20. 20 bits. So means it will be 2 raised to power 20. That is big number. Then block size. What about the block size? How many host bits? 4. That means our block size is 16. So if I have to design my first network, I'll say 100.0.0.0. Correct? Second network will be 100.0.0.16. And like this, if we keep on adding, the last network is going to be 240. So means my last network, it is going to be 100 dot. Is it 0?
Hundred dot.
So why did you agree here? 100.0. Network bits, guys. The network octets, they are going to remain same. Okay. So according to our new subnet mask, this octet is also network, this is also network, and this is also network. So here also we have to do 100.100. Okay. This will be because only 4th octet is having the host, right? Okay. So the last network will be 100.100.100.240. Okay. And before this, there will be a network 100.100.100. Before 240. 28 or 2 to 4.
240 minus 16.
240 minus 16. 2 to 4. This will be your second last network. So if we have to write the first valid IPs, so this will be 100.100.100.1. And in this network 100.100.100.17. In here it is 100.100.100.225 and 100.100.100.241. And then total we are having 16. So
255 last.
So this is ending at 16, means our first network will be ending at 15. So last valid IP will be 14. So 100.100.100.14. Okay. Then 100.100.15. Same way. 100.100.100. What will be the next? After 16, that will be 32. So means this will be last valid IP will be 30. And this will be 100.100.100.31. Then this is starting at 241 means, 240 starting means 239 is the end. 100.100.100.239. And this will be 100.100.100.238. And in here, 100.100.100.255, 100.100.100.254. Okay. And these are your network ID, first valid IP, last valid IP, and broadcast address. Okay. So according to this, if you want to know our own IP, according to our example, what will be the network ID? and broadcast address. See, what is the block size? 16. First is 0. Second is 16, 32, 48, 64, then 80, 96, and then after 96, there will be some value. So we are having 100, means it is starting at where? 96. So network ID we came to know 96. But for broadcast address, what is the next value? 112. So means 111 will be the broadcast address. Clear? So network ID will be 100.100.100.96 and 100.100.111. Is it clear? Clear, right?
That means 2 raised to power 20, a number of network we can create using 16 also.
No. It means basically, if you are using a range, a network from class A, okay, and if you are doing the subnetting with /28, so that means equally you can divide 2 raised to power 20 networks, because having 16, if we consider one network of class A, 1,67,77,216, but for doing /28, we are getting only 16 addresses network. So how many total networks there will be? In 1 crore, how many total networks will be there? That is the number of networks. Okay. And this will not be useful because we'll still be studying one more concept about FLSM and VLSM. Okay. So main focus should be on the block size and calculating the network ID and broadcast addresses. Because we don't care how many networks will be divided, because we are not going to design all of those networks. We just have to focus whatever IP is given to us and what is the / value, and accordingly, what will be our network ID and what will be the broadcast address. Because this will be helpful in our routing part and entire network communication part. So you have to focus on this.
Block size is always 2 to the power the host.
Yeah, host. Block size is 2 raised to power host.
If we get the practice to copy.
Yeah, I'll be dropping the practice questions in the drive today. Okay, so you can practice. And I'll be telling you shortcut method also, so that you don't have to do all this configuration. Because your ultimate goal, if you see, to calculate the network IDs and broadcast address, if you get the block size, everything is done. So by looking at the / value directly, you can check that, okay, 28 means I will have four host bit. 4 host bit means 16 network IDs. 16 addresses will be there. My block size is 16. Now you can know the network ID and broadcast address just looking at the / value. You don't need to do all this configuration, calculating the subnet mask and all. You have to calculate the subnet mask when you want to assign the address. Okay. And make sure you remember this subnet mask for these / values. Tomorrow I'll be telling you. One is the / at least from 24 till 30, you must remember. Okay. From 24 till 30, you must remember. So tomorrow I'll be telling you this also. I'll give you a table. So in that table, everything will be there. Is it clear? So any doubt with the class full or classless subnetting in any class A, B, or C? I'll be dropping practice questions today in the drive, so you can practice. And if you have doubt, you can drop in the group. Okay. And those who have not provided me the who has not pinged me in the WhatsApp or who is not in the group, they'll ping me today. So I'll provide them the link. Okay. So any doubt with this classless and classful subnetting right now? No? Okay, then I'll stop the recording.